This video is a concept part for the polar representation of a complex number. So in this we'll see how to write the polar representation of the standard form of complex number, how to find argument, how to find modulus, those all. So standard form of a complex number is z is equal to a plus ib. So how to represent a complex number in a Cartesian plane? We cannot represent a complex number in Cartesian plane. Why? Because Cartesian plane real numbers are represented, but we can represent a complex number in an argand plane. How does an argand plane look like? Argand plane exactly looks the way the Cartesian plane looks like, but in an argand plane, this is called ARGAND. In an argand plane, the horizontal line represents the real part of the complex number. Here A is the real part of the complex number, and the vertical line is the representation, or on the vertical line the imaginary part of the complex number, those points lie. So imaginary part of the complex number, which is the imaginary part? B. B is the imaginary part of the complex number. Then how to locate a point in the argand plane? We represent the coordinate or the ordered pair P, A, comma B in the argand plane. So this is first quadrant, second, third, fourth. So a point in the first quadrant A, comma B. The point of intersection of the horizontal line and vertical line in an argand plane is called a pole. The way the point of intersection of the horizontal line means x-axis and y-axis in Cartesian plane is called origin. In argand plane, the point of intersection is called pole, but we can represent it with a 0 as well as O. So this is called pole. That is why a complex number can also be represented in form of the polar representation. Means here the angle that OP makes with x-axis, positive x-axis or positive horizontal part of the axis, that involves in this. So first we'll join OP. Then from P we drop an altitude. So A is this part of the horizontal line and B is this part of the vertical line. The angle that is formed by OP with the positive axis, x-axis, is called the argument of the complex number. So you call this as some x. OP distance is the modulus of the complex number, which is r. Why r? Why? Because with this we can draw a circle. This time the circle may not be a unit circle. For the polar representation, we should know certain things like cos x and sin x. Will find what is cos of the angle that is formed here. Cos of the angle is adjacent to hypotenuse, and this indicates that A can be written as r cos x. Similarly, sin x is opposite to hypotenuse, means B by r, and this is B is r sin x. And what is r? R is actually modulus of the complex number, which is a square root of a square plus b square. Now, standard form of the complex number is written as z is equal to a plus ib. In that case, polar form. Polar form is otherwise known as the trigonometric form of a complex number, representation of a complex number. Polar form is written as z, which is a plus ib. A is what? A is r cos x. R cos x plus A I have written plus I wrote ib. So I am writing I, and what is B? B is r sin x. So polar form of the complex number means a trigonometric form of a complex number is r is highest common factor, r is out. So cos x plus I sin x. So this is the polar form. When we represent a complex number in polar form, we want the modulus of the complex number, which can be calculated using this formula. Also, we will require to know the value of x. This x, value of x is called the argument of the complex number. So there is a particular way to find the argument of a complex number. Argument of a complex number, if the point, the complex number will be in form of a plus ib. So if a comma b, that means that this ordered pair lies in the first quadrant, then argument x is theta itself. And how to find theta? We will go for tan theta every time. Tan theta is, tan of this is what? Opposite to adjacent. Opposite is a b, adjacent is a. So tan theta is a b by a. So we should find theta. Theta is what? Theta is a tan inverse of a b by a. So first we should find theta wherever the point P lies out of the four quadrants. So first we should know theta. Theta is a tan inverse a b by a. Just remember that tan theta is always calculated using b by a because opposite to adjacent. Now if point P lies in the first quadrant, then argument, which is the angle inside this right triangle, is same as a positive theta. But if this point lies in the second quadrant, then argument of the complex number is the angle that is formed inside this right triangle. How to find this angle? This angle is in anti-clockwise direction we should go for, is this angle. And what is this angle? This is 180, means a pi, minus this angle. You see, from the positive direction, full angle minus up to this angle. This angle we can call it as a theta. So pi minus theta, that means from the full angle if we subtract this part, we are going to get this, as simple as it is. So every angle in the second quadrant will be in form of a pi minus a theta. Pi is a known angle, 180 degrees, which is pi radians. Theta we should find. Theta, for that every time come to this formula. Tan theta is b by a. So b will be known, a will be known, then you only have to find that tan of which angle is that fraction. We know tan of some angle is root 3, some angle is 1, some angle is 1 by root 3. So we can find which angle it is. Okay. So if the point P lies in the third quadrant, for that I prefer to draw separate diagram because lot of messy it became. So if the point P, the ordered pair a comma b, a is the real part of the complex number, b is the imaginary part of the complex number, lies in the third quadrant, then from here when we drop an altitude, a is at this length and b is going to be this length, and the angle inside this right triangle is called the argument of the complex number a plus ib. How to know this angle? This angle is actually this full angle minus this angle. That means from this full angle when we subtract this, we are going to get this angle. But this time the angle rotation is in clockwise direction, and in clockwise direction this angle is a negative pi and this angle is negative of some theta. So every angle in the third quadrant, every angle in third quadrant is in form of minus pi minus of minus theta, means minus a pi plus a theta. Now if this point whose ordered pair was a comma b was in the fourth quadrant, then when we join OP, we get this angle. This angle itself lies in the right triangle and this itself is the argument of the complex number whose real part is a, imaginary part is b. Here this angle is in clockwise rotation, so this angle is minus theta. So every angle in, every argument in the fourth quadrant is minus theta. So I do the fair part of this. How to decide argument of a complex number. So first consider the argand plane, where the horizontal line is a representation for the real part of the complex number. Vertical line is a representation for the imaginary part of the complex number. The point of intersection is called pole. This is pole. We can write it as O also, but it is called pole. That is why that representation is called polar representation. Now, argument of the complex number in the first quadrant is always theta. How to find theta? We will apply tan theta is equal to B by A. What are A and B? That point A comma B. A is the real part of the complex number, B is the imaginary part of the complex number. The complex number is A plus IB. So B by A. And we can guess which tan of which angle is this fraction, and that angle is the argument of the complex number. If the point or the ordered pair due to the complex number lies in the second quadrant, every angle in the second quadrant is in the form of pi minus theta, and theta we are going to find using this relation. Every angle in the third quadrant is in form of a minus pi plus theta. Only we have to find theta from the given standard form of the complex number, and then minus pi plus theta will give us the argument of the complex number. What is argument? Argument is that angle that you see in the right triangle formed due to this ordered pair. So this is the argument. If the angle lies in the fourth quadrant, then the argument is minus theta. Why? Because the terminal ray is turning in clockwise direction, and in this direction angles are negative, in this direction angles are positive. So this is about the arguments in the four quadrants. So this is the argument in the first quadrant, argument in second quadrant, in third quadrant, and fourth quadrant. Standard form of a complex number is always A plus IB. This one in ordered pair is A comma B. First the real part of the complex number, next the imaginary part of the complex number. The polar form or the trigonometric form of the complex number is A. How to find A? See, this is A, this is a B, and of course this is the modulus of the complex number R. So from here we can know that cos x is A by R. So A by R is cos x. So A is R cos x and B by R, opposite to hypotenuse, is a sin x. So B is R sin x. So A is R cos x. X is the argument. These are the standard arguments in the four quadrants. So much research is not wanted. Directly if you can remember, then you can answer. Plus I. B is R sin x. Highest common factor if you take common, Z is R cos x plus I sin x. So x is argument. Remember what is the meaning of principal argument in this case. Principal argument means amplitude or the angle that lies in that right triangle formed by that ordered pair with respect to x-axis. Principal argument is the value of x. Which x? This angle that you see in the right triangle. The value of x that lies in the length of 0 up to 2 pi. So any length of 2 pi angle, in that length if x lies, that angle is called the principal argument. So principal argument is that angle that lies in this range. Also if that angle lies between minus pi and plus pi, then also that value of x is called the principal argument or amplitude of the complex number Z. With this concept, we will answer exercise 5.2. In exercise 5.2 of chapter 5 complex numbers, class 11th mathematics, the first question is find the modulus and arguments of each of the complex numbers given in these questions. We are supposed to find the modulus and arguments of the given complex number. There are two of them. So before finding the modulus and arguments, first we have to write the given complex number in standard form, means a plus ib form. So here this can be written as -1 plus I times minus root 3 or negative root 3. Then compare this with the standard form, z is equal to a plus ib, and in this way we can pick up the value of a as well as b to get ready with the ordered pair a comma b. So here a is -1 and b is negative root 3. So first we'll find the modulus of the complex number. Modulus of the complex number is generally it is denoted with r because we are about to draw that unit circle or the circle of radius r, which is square root of a square plus b square, which is square root of -1 square plus negative root 3 square. This in turn is -1 square is 1, negative square is positive, root 3 square is 3, which is root over of 4, and this is 2. So modulus of the complex number is 2. Now we should find argument. For finding argument of the complex number, we have to draw the argand plane, not the complex plane. Argand plane means a plane in which complex numbers are represented. Cartesian plane means a plane in which real numbers are represented. So in argand plane, the horizontal line represents the real part of the complex number and the vertical line represents the imaginary part of the complex number. The point of intersection of a real part of complex number and means a horizontal line and a vertical line is not called origin, it is called pole, but we can represent it with a letter O and the number 0. This is called pole, that is why we can write the standard form of complex number in polar form, means a trigonometric form. Now to find the argument, first we have to see the ordered pair a comma b, which is -1 negative root 3, lies in which quadrant? Both of them are negative, so this lies in the third quadrant. So I am representing the point P, whose the ordered pair is -1 minus root 3. So from this point, when I drop an altitude on x-axis and join OP, then we will know that the -1 is this part of the right triangle and negative root 3 is this part of the right triangle. This is negative root 3. Now the angle that is formed inside this right triangle connected to the origin, means pole, this angle is called argument of the complex number. This angle, let us call it as x. So how to find this angle? This angle, I am just mentioning what is the argument of the complex number. Argument of the complex number is the value of the angle x. To find this angle, what we have to do is we have to rotate this ray in clockwise direction. In that case, this angle is this complete angle. In clockwise direction, every angle is a negative. Okay. So this angle is a negative pi, negative 180. So from this we have to subtract this angle. And what is this angle? This angle can be represented as a theta, but it is in clockwise direction too, so it is negative theta. So this angle is, from this full angle we have to subtract this, then this point location appears. Every angle in third quadrant is in form of negative pi minus, means this minus this. So minus pi minus of minus theta, means minus pi plus theta. So this angle x is from the big angle, subtract this so that you get this. So x is this. Now we have to find minus pi plus theta. Minus pi is a known angle, means negative 180, but theta we should find. So there is a procedure of finding theta. since tan theta is always, when we know a complex number in form of a plus ib, tan theta is tan theta is b by a. So what is a b? B is a negative root 3 and a is negative 1, means it is root 3. So tan theta is root 3. Tan of which angle is root 3? Tan 60 is root 3. So this is pi by 60, no? So pi by 3. So tan of which angle is root 3? Tan of pi by 3 is root 3. So tan theta is tan pi by 3. On comparing, we understand that theta is pi by 3. So this angle is pi by 3. So what is argument? Argument of the complex number is x, and x is this. So x is minus pi minus of pi by 3. So okay, it is not minus, it is plus. Theta is pi by 3. So minus pi plus pi by 3, which is minus 3 pi plus pi by 3, which in turn is negative 2 pi by 3. So argument of the complex number is minus 2 pi by 3 and modulus is 2. Now we'll go for the second question. In this question also we have to find modulus as well as argument. The second question, we are given the complex number z, which is a negative root 3 plus I. So first we'll write this in standard form. Standard form is a negative root 3 plus I times 1. Standard form of complex number is a z. Z is a plus ib. So from here we will know what is a and what is b. So here a is negative root 3 and b is 1. First we'll find modulus. Modulus of the complex number z. When we draw the diagram, radius of the circle r is root over, means square root of a square plus b square, which is square root of negative root 3 square plus 1 square, which is root over of 3 plus 1, which is root 4, means 2. Modulus of the complex number is 2. Now we'll find argument of the complex number. To find argument, first we should know in which quadrant of this argand plane. This plane is called ARGAND. Argand plane, not Cartesian plane. In argand plane, we represent complex numbers in form of ordered pair. So for the ordered pair, the point P is A comma B. This is the ordered pair. This point is actually root 3 comma 1. So this is x comma y, means horizontal line information and vertical line information. So this is negative, means this, and 1 is positive, means this. So the ordered pair negative root 3 comma 1 lies in the second quadrant. Okay, so I'm connecting this to the pole, means in argand plane, what is a pole? In Cartesian plane, that is called origin. So this is 0 in fact, and this point is root 3 comma 1. So from here I drop a perpendicular so that this part on the horizontal line is a negative root 3 and this part is 1 unit. And this angle x is called argument of the complex number. So argument of the complex number is x. And how to find this angle? This angle is in anti-clockwise this pi minus anti-clockwise theta. That means from this full angle we have to subtract a theta to get this angle. in anti-clockwise direction, the angles are taken positive, and every angle in second quadrant is in form of pi minus theta. So x is pi minus theta, and now we should find theta. How to find theta? We'll go for tan theta. Tan theta is actually b by a, and we know that b is a 1, a is negative root 3. b by a means 1 by negative root 3. So tan theta is a negative 1 by root 3. So negative tells in which zone the angle is. Tan of an angle is negative in second quadrant. So you should avoid looking at the negative sign, only look at 1 by root 3. Tan of which angle is 1 by root 3? Tan 30 is 1 by root 3. So we will write this as a tan pi by 6. Negative tells the angle's location. In this zone, tan is negative. This zone only sine and cosec are positive. The rest all trigonometric ratios are negative. So tan pi by 6. So theta is pi by 6. So in place of theta, we'll write pi by 6. Argument of the complex number is x, which is pi minus pi by 6, which is a 6 pi minus pi, so 5 pi by 6. So argument of the complex number is 5 pi by 6, and modulus is 2. 5.2 exercise, third question to eighth question is convert the complex numbers given in this in polar form. That means we are given in standard form, we have to write them in polar form. This is the standard form, general form of a complex number. To write that in polar form, it's a trigonometric form. We have to find its modulus as well as argument. So first we are writing this in standard form. Standard form is in form of a plus ib, that is 1 plus I times a minus 1. This one is written in this form. Standard form of a complex number is a plus ib, and here we can find what is a and what is a b. So a is a 1 and b is minus 1. So the ordered pair a comma b is 1 comma minus 1. Where this coordinate lies, or where this ordered pair lies, this ordered pair in the Argand plane lies in fourth quadrant. Plus 1 is this, minus 1 is this. So the point lies in this zone. Plus 1 minus 1, and this we connect to the pole, and the angle made here is this angle. So from here, when I drop a perpendicular, this is a 1 unit and this one is minus 1 unit. So the angle that is formed in the triangle, that angle is the argument of the complex number. So this is x, and this angle directly, every angle in the fourth quadrant is negative of theta. So we should find theta, and then we know the argument. Argument means the angle that is formed in this right triangle. First we'll find modulus. Modulus of the complex number is r, and which is this r? This r is this one, OP. OP is r or mod z. OP is a square root of a square plus b square, which is square root of a square, means a 1 square plus minus 1 square. Root over of 1 square plus 1 square is 1 plus 1, 2. So root 2. So modulus of the complex number r is a root 2. Mod z is square root of 2. Then we'll find argument of the complex number. Argument of the complex number is x. In this case, this point lies in the fourth quadrant. So argument is minus theta. How to find theta? We'll go for tan theta. Tan theta is a b by a. And what is a b? B is a negative 1, a is 1. So minus 1 by 1, which is minus 1, means tan theta is a minus 1. The minus sign indicates that this angle is not in first quadrant or third quadrant where tan stays positive. So whenever tan of an angle is negative in second quadrant and in fourth quadrant, but based on the coordinate or the ordered pair, this point is here. So tan of an angle is a negative in the fourth quadrant. In fourth quadrant only cos and sec are positive, rest all t functions are negative. So we should not care this negative sign. This indicates the location of the angle. So only we should look into 1. Tan of which angle is 1? Tan of 45 degrees is 1. Means tan of pi by 4 is 1. So tan theta is a tan pi by 4. Pi by 4 means 45. So on comparing we get theta as pi by 4. So argument is minus of pi by 4. So we got the modulus and argument of the complex number, which is minus pi by 4. Now we can write the polar form. So how to write the polar form? See, very simple. When we have a point, the ordered pair A comma B, and this is the origin or the pole, and when we drop an altitude, A represents this zone, B represents this part of the right triangle, and argument means x is this, and this is the modulus R. So for this right triangle, see, cos x. Cos x is what? Cos x is adjacent to hypotenuse, means A by R. That means that A is R cos x. You remember this. And then we go for sin x. Sin x is opposite to hypotenuse, so B by R. On cross multiplying, we will get B as R sin x. So we have A and B with us. Now we are told that Z, our complex number, is in form of A plus IB. A plus IB. This is a standard form or general form. Now the question is, we have to write the complex number in polar form, means a trigonometric form. So what is A? A is R cos x, and what is B? B is R sin x. So in polar form, the complex number is written as R cos x plus I times R sin x. What is highest common factor? Highest common factor is R. In the bracket we have cos x plus I sin x. So the trigonometric form or polar form is R. R is what? Square root of 2. R is a square root of 2 times the cos x. X is what? Pi by 4. Pi by 4. Minus pi by 4, sorry. Plus I sin minus pi by 4. So polar form of the complex number is a z, which is a square root of 2. Cos of a negative angle is cos of that angle. Cos minus theta is cos theta. So this is cos of pi by 4. Sine of a negative angle, sine minus theta is minus sine theta. So this becomes minus of plus minus I sine pi by 4. So this is the polar representation of given complex number. Question number 4, we are given a complex number. We have to express the complex number which is in standard form to polar form. So first we have to write this in standard form. So in standard form is z is equal to a plus ib, and hence a is -1 and b is 1. So the ordered pair p, which is written in form of a comma b, is -1 comma 1. So first we will find the modulus of the complex number, and then we'll find argument, and then we will write this in polar form. So the point -1 comma 1 lies in the Argand plane in the second quadrant. So first we'll connect the point to the pole, call it as O, and from here when we drop a perpendicular, this part is the x coordinate, that is -1, the real part of the complex number, and this part is the y component, that is the imaginary part of the complex number. The angle here formed, this angle is called argument of the complex number. How to find this angle? This angle is formed by the anti-clockwise rotation of the ray with respect to the initial ray. So this is pi, which is positive. In anti-clockwise direction, angles are taken positive. From pi we have to subtract this small angle, that is a theta. So x, here x is pi minus theta. That means from this complete angle we subtract this to get this. So in a way we should find theta. So what is theta? What is x? X is argument of the complex number, which is pi minus theta. Every angle in second quadrant is in form of pi minus theta. For theta, we'll go for tan theta, which is b by a. B is 1 and a is -1. So 1 by -1. So tan theta is -1. Tan of an angle is negative of a number, indicates that the angle is, tan theta is only positive in third quadrant and in first quadrant, and negative in second quadrant and fourth quadrant. According to the location of the point, tan of this angle lies in second quadrant, and in second quadrant tan is negative. So this is about the location. Just you have to see tan of which angle is 1. We know that tan 45 is 1. So tan of pi by 4. So theta is, on comparing, theta is pi by 4. So here theta is pi by 4. So x, which is argument of z, is pi minus pi by 4, which is, on taking LCM, turns out to be 3 pi by 4. Argument of the complex number is x, which is 3 pi by 4. Now what is modulus? Modulus of z is written as r, which is the square root of a square plus b square. So square root of -1 square plus 1 square, which are the a and b values. Square root of 1 plus 1 is a 2, so square root of 2. So the standard form is z is equal to a plus ib, and the polar form. Polar form means a trigonometric form of the complex number is generally written as r cos x plus I sin x. R is the modulus of the complex number, which is this length, OP length. X is the angle inside this right triangle. So modulus is a root 2 times cos of x. X is 3 pi by 4 plus I sin 3 pi by 4. So this is the polar form of the given complex number. Question number 5. This standard form we have to write in polar form. So first we will write z in form of a plus ib. So here this is a and this is b. So the ordered pair is a comma b, which is -1 comma -1. Where does this point lie? In the argand plane. Argand plane, the horizontal line represents a real part of the complex number, and the vertical line represents the imaginary part of the complex number, and the point of intersection of horizontal line and vertical line is called the pole. We represent it with O. The point of this lies in third quadrant. Why? Because both of them are negative. The real part as well as the complex part are negative. So we join this, and from here we drop an altitude. So this is the -1, the real part, and -1 is also the imaginary part. And the angle that is formed in this triangle, actually this direction, is the argument of the complex number. Every angle in this zone in third quadrant is in form of -pi plus theta. Why? Why? Because the angle, the ray, terminal ray, rotates with respect to the initial ray in clockwise direction. So this angle, the angle that is formed in the right triangle, is this minus pi minus of theta. Minus pi minus of theta is minus pi plus theta. So first we'll find the modulus of z, which is r. Which is r? R is OP, which is square root of a square plus b square, which is a square root of minus 1 square plus minus 1 square, which is a root over of 1 plus 1, 2. So mod z means r is a root 2. We'll require this while writing the polar form. And then we need argument of the complex number. Argument of the complex number is that angle that is formed inside the right triangle x. And that angle, since point P is in the third quadrant, the angle is always in form of a pi plus a theta. If argument, that means angle, this angle lies in a length of 2 pi, then it is called the principal argument, or else every other argument value is called the general solution. So this is principal argument if this angle lies between 0 to 2 pi, or 0 from 0 up to 2 pi, or minus pi up to pi. The length should be 2 pi. So how to find theta? Since tan theta is always calculated using b by a, you just remember this to find this. B is, this is a and this is b. B is minus 1, a is also minus 1. So minus 1 by minus 1, which is plus 1. Tan theta is plus 1. And it is so correct because in third quadrant, tan of an angle is positive. Tan of which angle is 1? Tan of 45 is 1. Tan 45 is actually pi by 4. So on comparing, we'll get theta is pi by 4. So here theta is pi by 4. So argument of the complex number is x, which is minus pi plus pi by 4, which is minus 4 pi plus pi by 4, which is minus 3 pi by 4. Now we'll write the polar form. Standard form is z is equal to a plus ib. Polar form is r cos x plus I sin x. R is the modulus, which is a square root of 2 times cos of minus 3 pi by 4 plus I sin minus 3 pi by 4. We can leave the answer like this, or we can write cos of a negative angle is positive cos minus theta is cos theta. So we can write this as cos of 3 pi by 4. But sine of minus theta is minus sine theta. So this plus becomes a minus I sine 3 pi by 4. So this is the polar form of the given complex number. Number 6, given complex number is minus 3, which has got only a real part. We have to write its polar form. So first we have to write this in standard form. So standard form is z is equal to a plus ib, but b is 0. So from here, standard form, when we compare this with standard form, a plus ib. So you can understand that a is this and b is this. So our ordered pair a comma b is written as minus 3 comma 0. In which quadrant this lies? Point is, it doesn't lie on in a quadrant. It lies on a real axis or the imaginary axis. So horizontal line is for real part of the complex number and vertical line is for the imaginary part of the complex number. So minus 3 means that this point is here in this location. Say this is minus 1, minus 2 and this is minus 3. So the point lies at this location. So this angle is pi. So argument of the complex number is pi. Argument of the complex number is pi, and modulus is square root of a square plus b square. So minus 3 square plus 0 square. So 3 square root is a 3. The polar form of the complex number is z is equal to r cos pi plus I sine pi. So this is the trigonometric form of the complex number. Number 7, we are given the complex number root 3 plus I. So we can write it as I1, so that on comparing this with standard form a plus ib, we can get the real part as well as the complex part. So the ordered pair P, A comma B is P of root 3 comma 1. Now this lies in the first quadrant. So I'm just locating the point here, which is root 3 comma 1. And from this point, when I drop an altitude here and join point P to the pole, means O, we will get this as root 3, the horizontal part, and the vertical part as 1. This part is the modulus of the complex number, mod z, and this angle that is formed, we call it as x, that is the argument of the complex number. So first we'll find mod z. Mod z is r, which is square root of a square plus b square, which is square root of root 3 square, means 3, plus 1 square means 1. Root over of 3 plus 1 is root 4, so r is 2. So mod z is a 2, we will need it. Then argument. For argument, first we should find tan theta. Tan theta is a b by a. B is, see, this is a and this is b, so 1 by root 3. Tan of which angle is 1 by root 3? Tan 30 is 1 by root 3. So tan of a pi by 6. On comparing this, we understand that theta is pi by 6. So what is argument of the complex number? Argument of the complex number is x. And since that lies in the first quadrant, it is the positive number theta itself, which is pi by 6. Now we'll write the polar form. Polar form of the complex number is r times, so r is a 2 cos x means pi by 6 plus I sin x means pi by 6. So this is the polar form of this complex number. The last question of exercise 5.2, we are given a complex number z is equal to I, means only imaginary part is there and real part is not there. We have to write it in polar form. So first let us write this in form of 0 plus IB. B is 1 actually, because I exists. Standard form is z is equal to a plus IB. So here we can pick up a and b. A is 0 but b is 1. The ordered pair a comma b is 0 comma 1, where this point lie in the Argand plane. In the Argand plane, on x-axis it doesn't exist, means horizontal line it's not there. On y-axis, means on the vertical line, it is in this location, that is 0 comma 1. This is the point. So this we connect to origin, and this angle is the argument of the complex number, and this is pi by 2. So argument of the complex number is x, which is pi by 2, means 90. Modulus of the complex number is r, which is a root over of a square plus b square, means root 1, which is 1. Standard form is z is equal to 0 plus I1. Polar form of the complex number is z is equal to r times cos pi by 2 plus I sin pi by 2. In fact, we can tell the number also because we know these values, but this is the polar form.